Okay, looks like we're live. Good morning, everyone. We're going to go ahead and kick it off here with Rory. It's kind of hard to know where to start when you're doing an introduction for Rory. He's obviously a legend in the industry. Many of you were familiar with him long before we walked in with the flyer or catalog to try and talk to you about that. Anyone who's used any of Rory's training equipment will tell you that the design and craftsmanship of his simulators is the best on the market. But his simulators are really only a small part. I shouldn't say a small part. They're a very important part, but they're only a part of the seamless training system that includes the curriculum, assessment, and presentations that your students need to not only be successful, but to also be safe. We're very proud to have him here with us today. And the whole package overall is what it is because Rory is first and foremost a powerful educator who's trying to make a major impact on the industry. He's not just producing a product to try and make a buck. And you'll see that as he presents these sessions today. So without further ado, I'm going to go ahead and kick it over to Rory.
All right, well, let me move forward. Well, first and foremost, I want to thank Dactic for putting this together and inviting us to be part of this really great event. Appreciate everything that Dactic has done. I also want to give a shout out to Consulab for also being involved with this event. So thank you kindly for that. And again, I really appreciate the fact that we've been invited to make these few presentations. This morning's presentation is what I call the lethal strike. And the lethal strike, just to give you a little bit of background, I've been involved with fluid power for most of my career, and it was evident to me as I worked on hydraulic systems that there was always a problem with trying to remove stored energy from the systems. In other words, if I was going to go and work on a component, remove a transmission line, etc., there would be this fear that there would be stored energy in the line because there was no way of detecting it. And unlike electrical circuits where you can take a voltmeter and you can make sure that the system is neutralized, that is really not the case with hydraulics. Well, obviously, I was aware of this, and I was trained in hydraulics. I wasn't somebody who was not trained in hydraulics, who was working on hydraulics. So I was always aware of those areas or those particular components that could store energy. For example, counterbalance valves, pilot operated check valves, accumulators. And so being aware, I wasn't the one who was going, I wasn't going to put myself in harm's way. I had met a number of people who had suffered injection injuries. And the first thing that concerned me was that they really had bad outcomes, mostly because they didn't know what to do. The problem, as you will see here during this presentation, is that a jet injection injury, regardless of how it's delivered, be it a diesel fuel, a high pressure a paint gun, a high pressure washer, these are all mechanisms that can deliver these debilitating injuries. So now we've got the issue of had they known, they would have been able to mitigate it. But what they did, because the injury is so innocuous, they don't report. And you will notice that there's a 6-hour window. If you look at what all studies show, there's a 6-hour window between getting injected and reporting to an emergency room, because basically an injection injury is a surgical emergency. I couldn't fix the problem, but what I could do was write a script and make a DVD, which in 2004 we called The Lethal Strike. And consequently, the idea behind the movie, or at least the DVD, was to make sure that people were aware of how to manage a jet injection injury. So it's sort of a interesting safety DVD from the point of view of it tells you what to do after you've suffered an injection injury, but it doesn't help you understand how not to get injected. And of course, I'm going to go into that during this presentation, so let's just move forward. First of all, the most common part of the body that is injected is the hand. And so let me start out by talking a little bit about this mechanism, which is extraordinarily complex. The hand consists of 29 major and minor bones, 29 major joints, at least 123 named ligaments, 34 muscles which move the fingers and the thumb, 48 named nerves, 3 major nerves, 24 named sensory branches, 21 named muscular branches, 30 named arteries, and nearly as many smaller named branches. Now, obviously, if you inject a substance into the hand, it's going to create some major complications. And this is one of the things that's really misunderstood. As we said, the hand is easily damaged if injured and exceedingly difficult to repair. So we have to do everything that we can to protect them. Bear in mind, of course, that mechanics, anybody that's in the service industry relies on their hands for all of the work that they do. This document, the book itself, examines the factors that influence the background, symptoms, treatment, and likelihood of a fluid injection injury, specifically identifying those people who are most at risk of suffering these types of injuries. All people who work on and around fluid power systems are at risk of suffering an injection injury. The people who are most at risk include those who maintain, service, repair, and troubleshoot fluid power systems, assembly line workers, diesel engine technicians, and workers who operate hydraulic powered tools. Now, there's the OSHA lockout standard, or if you will, the control of hazardous energy standard, is interesting in that there's an emphasis on never discharging high pressure liquids to the atmosphere. What do you do when you're dealing with machines that do that by design? Example, paint guns, grease guns, high pressure washers. And so there seems to be this, it's an interesting concept when you look at those which are confined liquids and those which are unconfined liquids. In other words, let's put it like this. The number one injected material is paint thinner, and grease is number 2. They're way up there. So the reason why people are getting injected with hydraulics or diesel with the common rail fuel, etc., is because we're going to the atmosphere. In other words, we're replicating what a paint gun or a high pressure washer does for a living. So really, the training is actually more important for those people who use paint guns and grease guns, etc. And I find it interesting that sometimes when I go to companies to do safety presentations, that they hold the oilers, they call them oilers, greasers, they keep them out of the training. And they say, well, they're not mechanics, and so they don't need the training. Well, they're the ones who need it more than anybody else. So it's really interesting that it is my strong opinion that this should be a topic that's covered in all technical schools. In fact, I would highly recommend that we try to put together a standalone, like I have in my training, I have a standalone safety presentation. And if I test students, it's a third of the test is based on theoretical safety and also a practical safety. In other words, if you have a lab, then I would basically be looking at the student's performance in the lab, and based on that performance, I would put the two together as, let's say, a total score for safety. Just an idea. A number of factors cause or contribute to the reasons why people who work on and around fluid power systems are at high risk of suffering liquid injection injuries. So here's the bad news. Let's get this out in front of us. OSHA's standard for the standard lockout tagout, which is the control of hazardous energy, is to me one of the most confusing standards I have ever read. I don't get it. It doesn't escape me. In other words, OSHA says that all forms of energy have to be brought to zero mechanical state. Verifiable, that is. Well, there isn't a hydraulic system out there. 99% of hydraulic systems do not have that ability to either detect or, as I like to call it, detect and diffuse stored energy. That's just not going to happen. So, number one, OSHA does include hydraulics, but looks the other way when it comes to, can you actually de-energize a hydraulic system? So in other words, the manufacturers themselves warn about the consequence of discharging oil to atmosphere. And if I had to say just global household names, Caterpillar, John Deere, they have strong warnings about the consequences of discharging high pressure oil to the atmosphere, stating both that it can both severely injure or kill people. Well, that's interesting because I don't know of any manufacturer's machine that you can actually de-energize safely. In other words, cracking a line is discharging high pressure oil to the atmosphere. It's an extraordinarily dangerous procedure. And then, of course, if you start looking at the different types of connectors, this makes this thing even worse because you can't crack, for example, a split flange connector because the O-ring is going to extrude. So this is very interesting when it comes to fluid power. In other words, let's cut to the chase. Fluid power is not recognized as an occupational hazard by federal, that's OSHA, Occupational Safety and Health Administration, and MSHA, the Mine Safety and Health Administration. And so that's all state and federal agencies, which means people who work on around fluid power systems are not required to undergo any type of training in fluid power. Moreover, less than 1% of companies provide it. So again, the diesel folks, the companies, which is confusing. I was at a mine in Nevada about a year ago, and I was required to go through lockout training before I went on the property, which was sort of, as I said a moment ago, sort of pointless because all diesel-powered equipment is excluded from the lockout standard. So isn't that interesting that OSHA requires companies to put everybody through lockout training on machines you can't lock out, that are not required to be locked out by law like an electrical panel, number one. Now, number two, you can't de-energize the hydraulic system. So what's the point? In other words, if a person was really knowledgeable about hydraulics and went through lockout training, if they actually got the message, they would refuse to work on a hydraulic system, just based on what you learned about discharging high pressure liquids to the atmosphere. So again, less than 1% of the companies I work, and I work across the entire, and have for decades worked across the entire country, and I've never been to one company that has a hydraulics safety training program. Oh, there's plenty of companies out there that will focus on a post-incident situation. Recently, there was a young man killed at a mine in New Mexico because of a porta power incident. In my opinion, the porta power was inherently unsafe by design. However, there's now a whole new interest in porta power safety as a result of there being an interest. So those particular mines now are doing porta power safety, which is, of course, reactive. And then what they'll do is, because we're not so ignorant about hydraulic safety, is they'll add something else after there's been another incident. So that sort of grows. In other words, let's put it like this: most of the rules that are in an OSHA manual are written in blood. So there's another rule that's written in blood. Licensed safety professionals only receive training in those jobs that are recognized by OSHA and MSHA as occupational hazards. Thus, they typically do not have skill sets needed to introduce vital safety guidelines, which are needed to protect workers. So let's just talk about the notable organizations: the American Society for Safety Engineers, Since there's no hydraulic safety at all, the safety people that go to these organizations for their training don't cover hydraulic safety. So the safety people go back to their facilities, and even though the whole production line is hydraulic, or all of the equipment they have is hydraulic, because the safety people aren't getting the input, they're not doing the output, and that is they're not doing hydraulic safety training programs. Without OSHA/MSHA oversight or regulations regarding the safe release of hydraulic energy, there are no safety design standards for the release of that energy. In other words, once again, OSHA does state that all forms of energy have to be able to brought to zero mechanical state, that all stored energy, the release thereof has to be controlled. But as any of you in the audience know, if you have, let's say, mobile equipment in your labs, you know as well as I do that any line you take off that machine, there's no verifiable way, there's no way to verify there's stored energy in there. So this creates the problem. This is now the driving force behind why I wrote the script and we made the DVD. Now, pressure is a measure of a force's intensity, and I'll come back to this in a little bit here. Just let's move forward. And let's talk about this, the injection injury itself. As we all know, a subcutaneous injection is an injection delivered via a hypodermic needle. Years and years ago, an engineer, a mechanical engineer, was privy to a person who got injected with hydraulic oil, and it triggered his design, which is now well known in the vaccine delivery industry as a jet injection device. Interestingly, the idea was triggered by somebody getting injected because they released the oil to the atmosphere. And so they have now what's called a jet injector device. They use these in the military, or they have, and they use it apparently to deliver chicken and pig vaccine. So it is a device that is designed to give a person a liquid injection with it's an electronic impulse that's delivered into this gun that delivers the medication. A jet injector device is a mechanism that delivers a controlled, tiny, high-pressure jet of medication into the skin without the use of a hypodermic needle. So there are four key differences between being injected with a jet injector medical device and getting injected with an industrial device like a paint gun or a grease gun. First, a jet injector will deliver a substance that will improve your health, and industrial device will deliver a substance that will maim or kill you. Next, a jet injector will deliver a predetermined amount of medication, and of course, one of the biggest problems that these ER docs and hand surgeons face is they never know how much substance, the quantity of substance that was injected into a person. They have no idea of knowing what it is. In other words, sometimes people who deliver chicken vaccines will inadvertently inject themselves, but they can say to the ER physician, I have 3 cc's of the substance inside me. So they know they have the specific quantity or amount. Next, a jet injector will deliver to a predetermined location in the body, whereas an industrial device, all a body is a target-rich environment for an injection injury to be delivered or come your way. It'll deliver to an arbitrary part of the body. Last, a jet injector will be administered by a medical professional, and of course, a industrial device will be administered by the action of a machine, or releasing, cracking a line, you know, the list goes on. How a typical substance injection injury occurs, and as you can see here from the illustration, you've got a cross-section of a flexible hose. Let's say it's at 3,000 pounds per square inch. A pinhole leak appears in the wall of the hose and releases a jet of oil which heads for the hand and, of course, effortlessly breaches the skin. Now, sometimes the question is, at what pressure will I not get injected? Well, the interesting thing is, according to studies, you can get injected at pressures as low as 100, but I recently had a student in my workshop who told me that they were taking a flange off a hydraulic pump. That's the intake of the pump. Of course, that's oil by force of gravity. And they took the bolts out, and it dropped. And the edge of the flange had a sharp edge, and the liquid backflowed into the wound, into the cut, and he had to go for debridement. So there it is, zero pressure, and yet he went for debridement, which of course I'll explain in a moment. Anybody who works with the following devices needs to be trained to avoid or understand how to avoid these kinds of debilitating liquid injection injuries. So let's just go through a few of them. First and foremost, just to give you a relationship to pressure in hydraulics, and a domestic hose pipe is 35 to 70 psi. You go into air brakes in a truck, it's 120 psi. Then you go to airplanes ranging from 3,500 to 5,000 psi. Volt torque devices, which are commonly used today, 10,000 psi. Then you go into the fuel systems. In my day, in good old diesel days in my day, when I went to school, we were before, that's pre-common rail, that's 2,250 psi, and now we're up to 44,000 psi. Start looking at a car wash, 1,000 to 2,500. We go into now the grease guns, 250 psi all the way up to 6,000, and in this case, lever operated type up to 15,000 psi. I've had actually over the years been told of a number of people. One particular mechanic was interested in knowing what a grease gun delivers. This is a pneumatic grease gun. So he stuck a Zerk into it and pulled the trigger while it was against his hand. Well, that had a really, really bad outcome, obviously. But that's unfortunately what happens when people just really don't know. They're inquisitive, they're adventurous. So we can say, oh, well, the guy was stupid, but actually he didn't know anything about the science behind what he was doing. So a lot of this is born of more ignorance than it is stupidity. People are just adventurous. They want to know what it is. What does it do? And so they may do that. Okay, let me give you another example, which is sort of along the same lines. So Dad is using a high pressure washer to wash whatever in the driveway, and he goes inside, goes inside momentarily. The kids are outside, but the kids are accustomed to drinking water out of the hosepipe. When Dad or Mom are working in the garden, they just pick it up and they drink out of it. Well, they saw Dad using this high pressure washer, so they picked the thing up and they put it in the kid's mouth and pulled the trigger. That's how quickly we get into trouble. Now, my understanding is the kid, normally that would be a really bad outcome. But my understanding is there was blood coming out of the child's mouth, but obviously got very lucky. But that's how quickly we get into trouble, because we don't understand this pressure, this whole philosophy of liquids under pressure. Hose crimping about 5,000 psi. The folks in the oil field industry are looking at hydraulic systems. Fracking is up to 15,000 psi. We go on to pesticide sprayers up to 560 psi. Porta powers, which are commonly used, which everybody needs to be trained on, 10,000 psi. And we go through paint, again, paint guns, starting out at 15 psi up to an airless type at 7,500 psi. And of course, the last but not least, water jets. You're looking at up to 95,000 psi. So this is a subject that people really need to understand. Pressure is something that people really need to understand. All right. High pressure injection injuries are actually rare. In 1972, a Dr. Shu did a paper, a study, in which he said 1 in 600 people reporting to NER was injected with a substance. That's in 1972. I can't find current data on that. It's impossible to find. But I do find this interesting. A lot of people, because I write a lot about this topic and I do a lot of teaching on the topic, but I get feedback sometimes from people that say, you make a lot of noise for a low frequency incident. Well, I get it. 1 in 600. First of all, isn't one incident too many? Isn't one too many? So I guess we have to focus on all of these to get a zero accident is what our target. Before it froze up.
Oh, okay. There we go. You're good again. Let's see. You were just talking about how one incident is too many.
All right. So let me take it from there. Are we good to go?
Yep.
All right. Sorry about that. All right. So again, let me just go back on that. So apologize for that glitch there. So we said 1 in 600 reporting. This is 1972. Obviously, it's grown since then. So my point is, I've never been to a company that has near miss, because a lot of companies today have adopted near miss reporting, but I've never seen a near miss written up on a person that's, let's say, cracked a line, taken a K-strain line off a pump, taken a line off a cylinder, and the oil missed them. In other words, so how many people have had a real narrow escape? It missed the finger, it missed the face. So I think that if we were to record, since of course every single mechanic out there that's opening lines is exposing themselves to an injection injury by the mere fact that that's the only way they can release stored energy, is this must be at an epidemic proportion. So this is something we can't take too lightly. And so I think it's only fair to look at the real numbers. And that is not what is reported, like 1 in 600, but what about the ones that were near missed, and or I call it a near hit is more realistically what it is, but it was never written down. One study showed that large surgical hand centers on an average have 1 to 4 injection injury treatments every year. And this is supported by, of course, a lot of studies. There's a tremendous number of studies out there on these injuries. The study supported Daliana and others, who cited that 8 patients were treated with injection injuries in a 5-year period in the Department of Orthopedic Surgery in the Larissa University Hospital. We go back to the 30s to look at where, in our case, in the US, Dr. Reese was the doctor who did the first study in 1937, where a mechanic suffered an injection of diesel fuel to the tip of his right long finger, as the report says. And of course, that's 1937. So obviously this has grown. The sad thing about it is really nothing has been done to mitigate these from the inception, if you will. Research concurs that injuries typically involves pressures in excess of 100 psi, punching a hole in the skin and soft tissue. Unless having direct contact with the skin, pressures below 100 psi are unlikely to have sufficient energy to cause an injection injury, unless the skin has previously been broken or is healing from a recent injury. As I said earlier, grease and paint thinners are up there. Grease is the material most injected, followed by paint, water, wax, paint thinner, cement, plastic, oil, and hydraulic fluid. Injection pressures are generally 2,000 to 10,000 pounds per square inch. Depending on the entry pressure, injected fluid can travel a significant distance from the initial site of entry. This results in more widespread tissue damage. Let's talk about why it's traveling. Mineral-based oil dissolves fat tissues. So you inject mineral-based oil into your digit, and it starts dissolving fat tissues, then it starts traveling. And this becomes a problem. This is where the 6-hour window comes into play, because now if it's traveling, you've got to stop it before it moves, let's say from the hand up into the upper arm, and then of course on into the torso. In other words, you'll see, most of you study this, or you go online and you look at it, you'll see that most of the time when the doctor can't get ahead, or the surgeon can't get ahead of it, then what they'll do is they'll take the limb off so that they stop it before it gets into the torso. The high pressure injection of fluid such as oil constitutes a medical emergency. Again, this is problematic, right? Because I've never been to a company in the US or anywhere in the world that has a management program or protocol for somebody who gets injected. In other words, they wouldn't know what to do. And if you went to your supervisor and said, I've got a pinhole in my finger, looks like a pinprick, and not necessarily bleeding. And if you were to say to your supervisor, well, I'm going to go to the ER, and you've got 500,000 hours of no lost time injuries, you're probably not going to go to the ER. And that's not because the company doesn't care about your health. It's more because most of the people in the company are naive about what just happened to you. So it's imperative that supervisors, managers, and everybody's on board with what a jet injection injury is. It requires rapid access to appropriate specialist surgical care, and that's why we need a plan. The injury is often worse than it will appear, and all medical personnel, including first responders, must be aware of the seriousness of the patient's condition. Prompt recognition of the injury and early treatment are essential to avoid a poor outcome, but of course they never guarantee that the outcome is not going to be poor. People who are at most at risk are people who work on and around hydraulic powered machinery. It doesn't matter whether it's mobile or industrial, hydraulic test benches, assembly line workers, diesel fuel systems, particularly common rail, grease guns, hydraulic power tools, water jet machines, spray paint equipment, and so on. Now, we design and build hydraulic training simulators. That's all we do. But hydraulic training simulators are covered in quick disconnects, which are prone to hydro-locking. So in the interest of student safety, we put a product on our trainers called safety bleed. So there is a component out there that can mitigate it. And so just to give you an idea, we just build simulators. We don't want students to get hurt. Consequently, we put, to mitigate these, we put a safety bleed device online. So any student that hydrolocks a quick disconnect can unlock it non-invasively, not a drop of oil to the ground. And so that's how serious we take this issue of safety and jet injection injuries. The age range of the patient varies between studies 21 to 59 years old, with the average being around 36. At present, there are no gloves that will protect a person from a jet injection injury. All right. The material injected, site of injection, and likelihood of amputation. The toxicity of the injected material is dependent on its chemical composition, lipid soluble, which means it's insoluble in water, cause greater tissue damage and grease, even when not under pressure, as I mentioned earlier. Paint solvents are more toxic than either paint or diesel fuel. One study showed that amputation was needed in 80% of the cases when paint solvent was injected. In the same study, amputation was needed in 20% of the cases where grease was injected. The problem is that if somebody gets injected, and let's say a mechanic gets injected out in the field and doesn't say anything because it's just a little wound, the problem is it will have no reaction for the first 2 days, but then cause extensive fibrosis, oleogranuloma formation, and draining sinuses, according to one study. Water and air injuries may cause further complications due to fungal or other chemicals, for example, sewage or oil lubrication. Clean water injection injuries require superficial debridement, which can be performed under local anesthetic. Broad spectrum to antibiotics and elevation close observation will always also be required. And of course, gas injection injuries like air, you'll oftentimes see people take an air hose, they'll have dust on their coveralls, they'll start blowing themselves off with the air. If they have an open wound and that air goes into an open wound, it's going to have a really bad outcome. Air embolism in the bloodstream, which is air bubbles in the bloodstream, and death have been reported. It's a really bad idea. Fluid viscosity also has a direct bearing on the extent of the injury. So the more viscous the fluid, the less it will spread. Paint does not disperse as far as paint solvent, which therefore affects a greater volume of tissue. As we said earlier, the most common site of injection is the non-dominant hand, on which the thumb, index finger, and middle finger is the most commonly injured digits for obvious reasons. This is because the device is most often held in the dominant hand, whilst the device being worked on, or in the case of a spray gun, the nozzle is being cleaned with the other hand. In a study, 5 of the 9 patients with amputations had paint injection injuries. This, of course, supports other studies. So Verhoeven and Hiner concluded that the injection of paint into the hand results in more cases of amputation than other materials. For example, solvents, oil solvents result in amputation in 50 to 80% of the cases, and whereas other materials result in amputation in 16 to 55% of the cases. This is a very important, the 6-hour window is very common in all studies, and that is the amputation risk is lower if wide surgical debridement occurs within the first 6 hours of injury. However, Loveday's research found that the average time between high pressure injection injury and emergency department attendance is 8 hours. 80% of people injured by paint and paint thinners required amputation, according to one study. Another study cited that where the pressure was more than 6,900 psi, the amputation risk was extremely likely. All right, now the symptoms. What we're going to do now is we're going to go through the symptoms, and then we're going to go and I'm going to show you the DVD which we made, The Lethal Strike, and we'll move on. So just let me go through the symptoms. We'll put on the DVD, and the DVD is a role play. We're role playing somebody looking for a leak. In this case, a loader, and then of course it all goes south from there. So let's just move forward. The point of entry may look very small and may not bleed. The area of the injury is usually be on the working surface of the hand. However, it may be located in any body area. Initially, the patient may not complain of pain, but may feel a numbness or increased pressure within the affected part. Damage in the early stages is normally related to the physical injury, as well as damage from the chemicals in the injected material. The affected body part will progressively become increasingly irritated with the patient complaining of throbbing pain. The injected material may cause additional injury. For example, it may burn. All right. So let's move on now to the DVD. So let me get out of this and go into the DVD.
Okay, so see.
Sorry about this. Let me just get rid of this thing here.
Okay.
Wow, that's interesting.
Are we trying to switch over to the video now?
Yeah, I'm trying to switch over the video, but it won't.
Okay, so I've got a desktop view here. I'm going to make this live for a second so that you guys can see what I'm looking at. It just disappeared.
Okay, you see that? Can you see it?
I can see it on your monitor there, let's let it play and let me see what the sound is like. If there's sound now, I can't hear it at all. Let's back up a second. Nate, can you? I see the browser, the file browser window where. So it looks different than what I'm seeing on your screen there.
Yeah. So we just need to share the video.
Yeah. So it's not what I'm seeing. The desktop that I'm seeing is coming from something different than what you're looking at. All I'm seeing is the file browser.
So you're just seeing this. Okay.
Yeah. Okay.
Is that better?
Yes. Give me 1 second here, and I'll
share it.
Okay. Go ahead and hit.
Jake, are you trying to get audio?
Not yet. I was trying to get the picture first. Go ahead and hit play, and we'll see if we got live audio. Okay, pause it again. Okay, up at the top of the screen there, if you move your mouse up near the top, you should have a share system audio in the drop down.
Yeah, we've got that. We took care of that. So you want to try it again?
Yeah, go ahead. Okay, there we go.
We're good?
Hey, Judy. I noticed a huge oil puddle outside under the machine while it was idling. We should probably get it looked at while it's in the shop.
Stan, you better take care of that before it gets any worse. And I don't want anyone running this until it gets fixed, okay? Look at that thing, it's already leaking.
Okay, I'll take a look at it and let you know what's up. Hey, Race, shock and loader, put the lock arm in place. I'm gonna go grab the test kit.
Sure. How's it looking?
Not good. Can't find it. Why don't you start it up, get the hydraulic system running, we'll see if that'll make it leak.
All right. You ready?
Yeah, start it up!
You got anything?
Roll the bucket back, hold the lever so the pressure builds up, and then maybe I can see the leak.
Okay.
You okay? Messing around with the hoses, it felt like something bit me.
What happened? Let's see it. Doesn't look that bad. Should probably still go talk to Judy.
Are you serious? It's not bleeding or anything. I mean, it's probably just one of the wires from the hoses. I bet that's what it is. I'm just gonna go grab a Band-Aid real fast.
All right. What's up, Stan?
Hey, how you doing?
Good. Good. Is your hand still hurting you?
It's starting to bug me a little bit, man. It's getting all red. It's starting to throb.
Don't be a baby. Just go home and put some ice on it. You'll be all right.
You think so?
Yeah.
Oh, hey guys, how'd that front end loader repair go?
It went pretty well. We found a stupid leak, but...
Something happened to your hand?
Oh, I was separating some of the hoses on the loader, and felt like something bit me.
Damn it, Stan. You know we gotta report that. We gotta report every accident, no matter how minor. Come on, we gotta go see Alan about this.
It wasn't even bleeding.
I don't care. We still have to go see Alan about this. Come on, both of you. Alan. Alan, you need to take a look at this. Come on, show him your hand.
Whoa. What were you working on?
Just working on a loader, looking for a leak.
I don't think I've seen an injury like this before. But I'm concerned enough about that I think he needs to go to the hospital to have that checked.
Are you serious? It doesn't hurt that bad.
Yes. We don't want to take any chances.
Okay.
Come on, let's get you signed out.
Stan, right?
Yeah.
So Stan, looks like here on your chart says that you injured your hand at work. Can you tell me what you were doing when you hurt your hand?
Well, I'm a mechanic. I was working on a machine, looking for an oil leak, and I was reaching in some hoses, and I felt like something bit me.
Okay. So right now, are you in a fairly substantial amount of pain?
It's not that bad, really. They sent me down here.
Scale of 1 to 10, where do you think you're sitting at?
Probably a 5 or 6.
Let me take a look at it here. So, can you go ahead and maybe make a fist for me?
No, that hurts me.
As
Yeah.
far as you can go. All right. Tell me if you start to feel a little tenderness. Okay. How about down here?
Not really. Not
Anything
too
down
bad.
there? What about if I
Yeah,
move
right there.
Right there?
Yeah, that hurts.
Pain there?
Yeah.
Okay. Stan, what I think we're gonna do is go ahead and write you a prescription for the inflammation, give you an anti-inflammatory, and maybe something for the pain. Of course, we need to make sure that you're current on your tetanus. Beyond that, I just go home and kind of keep your eye on it, take it easy, and of course, if it gets any worse, you need to come back and see us. But if you have any questions, you can always give us a call as well.
Well, do you think I should ice it?
Yeah, I'd recommend icing 20 minutes on, 20 minutes off. Usually is a good way to do that. So,
Okay.
all right.
Thanks.
Honey, what's wrong?
I need to go back to the ER. I need to go right now.
Okay, I'll go get the car.
Stan, you're back. What's going on with the hand there?
Dr. Meyer told me to come back. It's gotten worse, and it's way worse. I can't sleep.
Okay, well, let's take a look at it there. Tell me, how's the pain doing? Where are you at on a scale of 1 to 10?
I'm 11 out of 10. I took the anti-inflammatories. The pain's getting way worse.
Yeah, Stan, that's looking pretty bad to me as well. You're pretty swollen there. Tell you what, I need to get you scheduled for an MRI. I need to get you in to see a hand specialist as soon as possible, okay? Don't worry, buddy. Hang tight. We're going to get you taken care of.
Hi, Stan. I'm Dr. Robinson. Dr. Myers told me that you had the hand injury and it's getting worse. How did this happen?
I'm a mechanic. I work on front-end loaders, and I was looking for an oil leak, and I was feeling around, and it felt like something bit me.
How long ago did you injure it?
I injured it yesterday.
Can you feel me touching these fingers? Can you move them? Okay. Dr. Meyer felt that this was just a puncture wound from the wire on one of the hoses. This is a much more serious injury. This is an oil injection injury. Oil at high pressure is injected under your skin. It's gone into your tendon sheaths and underneath your skin. There's been inflammation that's occurred since then. It's built up pressure and it's compressing your arteries and your nerves. And it's causing damage to these fingers. We're gonna have to do surgery as soon as possible to try to save this hand.
Am I gonna lose my hand?
I'm pretty sure that he's going to lose this finger. You can see that it's black. That means that the blood supply has been compromised for a long time, that the skin has actually died. I'll try to save as much of this finger as I can. I won't know how much of the rest of your hand I can save until we get to the surgery.
I can't lose any fingers. I'm a mechanic. I need my hands.
Honey, are you sure? Are you sure you can lose his hand?
If we had operated right away, we might have been able to save everything. But at this point, this finger is black. It's already dead. There's nothing we can do to save this finger. I won't know how extensive the damage is until I actually open it up and look at it.
When can we get him into surgery?
I want to find the next available operating room, and we'll get him into that room as soon as possible. I'll go try to look right now and see if there's one available. Well, the surgery's over. Stan did well. He's in recovery. We were able to save most of his hand. The damage wasn't just isolated to where the oil penetrated under his skin, but it dissected all the way through the soft tissues. It built up pressure on the arteries and the nerves, and it damaged them. We had to remove the index finger and part of the middle finger. Stan should be able to start rehabilitation in a few weeks. We won't really know what function he has in his hand till months after that. Unfortunately, that's the best prognosis I can give you at this point in time.
Thank you, doctor.
This accident occurred at 3,000 psi. Injection injuries can occur at pressures as low as 100 psi. Oil under pressure will penetrate every type of glove, safety or otherwise, currently available. There is no type of glove that will protect hands against oil injection injuries. High-pressure injection injuries of the hand are not common, but occur with enough frequency, and the consequences of mismanaging them are so serious that all victims, supervisors, emergency medical technicians, safety personnel, and primary care physicians must be able to diagnose them. The outcome of the injury is dependent on the site of injection, the type of material, the amount of material, the velocity of the injected material, and prompt and appropriate management. Successful management of an injection injury involves awareness of the impending problem, rapid referral to an emergency department, and immediate consultation with a competent orthopedic surgeon. According to studies, amputation risk is much lower if surgery occurs within 6 hours of the injury. The clinical presentation of a patient with a high-pressure injection injury is usually benign and subtle. This may lead to mismanagement or minimization of the patient's complaints. In Stan's case, the emergency department triage physician was unaware of the potential severity and initially misclassified his injury as non-urgent. If you suffer an injection injury of any type, take these crucial steps. Report the incident to your supervisor immediately. Do not drink or eat in anticipation of undergoing surgery. Arrange to be taken to an emergency medical facility immediately. Take the injected material's MSDS form with you. Application of a tourniquet is not recommended. If the emergency room physician or nurse misclassifies your injury, consult a hand surgeon immediately.
While you're getting that pulled up, I do have a question from Bob at CCAR who asks if, he says, Pertec markets a glove they claim is injection resistant to 700 bar. What is your opinion of this glove?
I would, first of all, I would read up on it very, there's no doubt I'd read up on it, because my understanding of these gloves is they only have certain protections in certain parts of the hand. And so therefore the best advice I can give you is to go to the specific glove manufacturer's claims and their liability, waivers, etc., and read up on them. So that's the best advice I can give you there. There's two companies. Pertec is another company that also has a glove, but again, I would really look at their literature and find out what kind of protection I get.
Good deal. Okay, thank you.
If anybody wants any more information about the lethal strike, it has three elements to it. One is what you just saw. The second one is an interview with Dr. Lewis, who was Dr. Robinson in the movie. And Dr. Lewis explains in layman's terms exactly what happens when a person gets injected. That was the second interview I did. And the third interview I did was with a hand surgeon. And so it's a 3-part, let's say, safety DVD. But if anybody who wants more information on it can go to the Fluid Power Academy. As you can see, the website up at www.fluidpoweracademy.com.